Hi guys, this is the definition of security and protection services. Means that a set of mechanisms and policies designed to ensure confidentiality, integrity and availability of system resources data. So the second one is authorization. Means that process of determining what an authenticated user is allowed to do. And the last one is encryption. That process of converting data into an unreadable format to protect it from unauthorized access during storage or transmission. How access control policies and privilege management protect system resources from misuse. The first one is define who can access what resources and under what condition. And the second one is controls and monitors the level of access or authority each user or system process has. Importance of implementing, auditing, monitoring, backup strategy. For auditing, process of recording and reviewing user and system activities to ensure compliance and detect suspicious behavior. So for monitoring, that means involves continuously observing system operation and network traffic to detect unusual or malicious activities in real time. And the last one is backup strategy. Involve creating and storing copies of important data so they can be restored after data loss or corruption.
So I will explain about topology. So the question is, a medium-sized company named Technova Solution is expanding its operation across 3 floors in a new building. Each floor has different departments. So for floor 1, administration and human resource consists of 5 workers using laptop and 1 printer. So this is the topology for floor 1. For floor 2, software development and R&D consists of 10 workers using high-spec desktop, 2 printer and 1 server. So this is the topology for floor 2. Floor 3, customer support and sales consists of 5 workers with desktop. And this is the last topology for floor 3. So now I will describe about instruction set. The instruction set architecture defines the complete set of operation and commands that a specific CPU is designed to execute, acting as the fundamental interface between the hardware and all software. It specifies crucial elements such as the available register, the fundamental data types, the addressing modes for memory access, and the exact binary format of the instruction.
Machine language is the absolute lowest level programming language, consisting entirely of binary code, zeros and ones, that the CPU directly executes without any translation. Each machine instruction is composed of an opcode and operands, which precisely map to a command in the instruction set. This is the computer's native language, representing the final output of all compilers and assemblers.
Now I will describe about this assembly language. Assembly language is a low-level symbolic language that provides a human-readable representation of machine code using simple, memorable mnemonic like add or move instead of binary sequence. There is a near one-to-one relationship between assembly instruction and machine code. Programmers use this language for direct hardware control, and a utility called assembler translates the code into the executable machine language. Microprocessor. There are several groups of instructions designed to write such code in the microprocessor. The first, arithmetic instruction, we have add, sub, and modulo, which they perform mathematical calculation. The second, data transfer. We almost use a move to which copy data between register, memory, and input-output ports. The last is logical instruction. For example, we have AND, OR, or an XNOR, which are to perform bitwise Boolean operation on data. Boolean?
Now, I will be finding D1 value after the instruction execution given below. For the first instruction, the low order byte of D0, 15, replaces the low order byte of D1, 55. The upper 24 bits remain unchanged. For the second instruction set, 15 plus 25 equals 3A. Only the low byte is affected. For the third instruction set, 3A minus 15 equals 25. Only the low byte is affected. For the fourth instruction set, D1 word, which is 0025, multiplies with D0 word, which is 0015. It turns into decimal, which is 37 multiplies by 21. This equals to 777 in decimal. Turning it into a hexadecimal, it becomes 0309. The fifth instruction set, D1 long word, which is 00000309, divided by 005 word. 0309, a hexadecimal turns into a decimal, which equals to 777. 777 divides by 5 equals 155 with a remainder of 2. 155 decimal will be translated into hexadecimal, which equals to 9B. For the sixth instruction set, D1 low byte is 9B. 9B turns into binary equals to 10011011. And 3C is a hexadecimal, which we have to turn into a binary, which equals to 00111100. And then 9B, to perform the instruction set, we have to do 9B and 3C, which equals to 00111000, which turns into a hexadecimal, which is 38. Now, the final answer will be 000200038. Okay. For the seventh instruction set, we have to do D1 low byte, which is 38, and D0 low byte is 15. We have to turn those two into a binary, which is 38 into 00111000. And for 15, we have to turn it into a binary as well, which is 000100101. Now, to perform the OR statement, we have to do 38 or 15, which equals to 00111101, which also equals to 3D in hexadecimal. And final answer will be 000200003D. Okay. Now, for the final statement, we have to do an EOR statement, which is exclusive OR. We have to get D1, which is 3D, and the given number, which is 25. We turn 3D into a binary, which is 00111101, and turning 25 into a binary as well, which is 00100101. Now, to perform our EOR, we have to do 3D EOR to 25, which equals to 00011000, which also equals to 18 in hexadecimal. The final result in D1 will be 000200018. Okay,